Hi, in this video I'm going to explain a small signal processing block which I wrote. This block is an adaptive filter which uses the least mean square algorithm as adaptive filter structure. Okay, first we have a Gaussian noise which is throttled, so the computer is not being overloaded. Then we use an FIR filter, which of course shapes the noise, and one part of this is fed to a spectral sink, so we can have a look how the FIR filter is going to shape the noise. But one part of this is going to our adaptive filter. The other part is the reference signal of the filter, and this is of course connected to the noise source. So at the reference port it gets all the noise samples, and over the other port it gets the shaped noise samples. And the goal is to use an adaptive filter to minimize the error between both of the inputs. And the error signal is, you can see here, and the error signal is going to a time sink. If one clicks on the least mean square block, you can set an FIR length. So in the least mean square block there is an FIR filter that is used to adapt to the other filter. We also have a multiplication factor, which in my case is set to a slider, because the value of the mu factor, the factor mu is used to set how fast the filter is converging, and we can change this with a slider, which we use here. We also have the possibility to change the tabs of the filter. And what is also very important to note, we have a message strobe here which sends every 5 seconds a reset command to the filter, which then resets all the tabs, and then we can see the arrows to reappear. Okay, after running the simulation, on the bottom side we can here see our shaped noise, so we can influence this by changing the FIR tabs. Okay, it has not a significant impact, but you can see the noise, the shape is changing of the noise. What we can see here in this block is the arrow. So every 5 seconds you can see an arrow reappearing, and it converges to 0 then. So now the filter is perfectly adapted. But if we change, of course, the filter response of our FIR filter, it needs to converge again. Okay, let's make the converging process slower. Okay, now you can see that it takes a very long time to converge. If we put the mu factor up, you can see it needs only a short time to converge. Okay, let's go back to our schematic here. We can also use the message tabs and send it to the filter. After the filter receives the string tabs, it puts out its current FIR tabs, which is very interesting, because if you look here, you can see our tabs are 111, 800 milli, 700 milli, and of course I already run the test. Okay, now, which is important to note, the filter has fully converged. So if you look here, our filters is 1, 1, 1, 0, 8, 0, 7, and 3 point something to the power with the 10 to the power of minus 10. So this is nearly 0. Okay, let's run the graph again and decrease the the mu factor, and we change it so you can see the arrow is pretty huge. And let's have a look at the debugging message. You can see here it needs some time to converge. Okay, now okay, it's not a good demonstration. Our third tab is not 1 anymore. We set it to, okay, let's reset it to 1.85. So 1, 1, 2. So we need to wait. So 0.19. So it's getting close to 1.8. Now we are close to, or we are exactly at 1.85.